All right, our next section is on theoretical and experimental probabilities. In order to talk about what the differences of those are, we have to know what probability is. Probability is the likelihood that an event will occur or happen, and we can represent it as a number between 0 and 1 that can be written as a fraction, decimal, or a percentage. It says a number between 0 and 1, but we are including 0 and 1. If the probability of event A equals 1, that's what this first one says, probability of event A equals 1, that means event A is guaranteed to happen. Event A could be anything, okay? I could say, what is the probability that the day after Monday is Tuesday? That is the day after Monday, so that is guaranteed to happen. That would have a probability of 1. On the other side of things, the probability of event A equals 0 means that cannot happen. So if I said what's the probability that the day after Monday is a 6 of clubs? That's not possible. That doesn't make any sense. That has a probability of 0. Most things are going to be somewhere in the middle, okay? Probability of event A equals 1/2 means that event A, whatever event A is equally likely to happen or not happen. So if I said, what is the probability that the day after today is Wednesday, maybe it'll happen, maybe it won't. Now that is a slightly misleading example because the day after today is Wednesday can only happen one way, but there are 7 total ways. But that's the idea of it can happen, it can't happen. All right. This number line gives us kind of a spectrum of things. If the probability is a 1, all the way on the right here, that event will happen, guaranteed, 100%. If the probability is 0 on the left, that thing cannot happen. It's not possible. And if it's in the middle, at 1/2, it's equally likely to happen and to not happen, okay? If it's somewhere in the middle here, towards the right, so in the middle of the top half, it is more likely to happen and less likely to not happen. Similarly on the left, this will be less likely to happen. Okay, the closer your fraction is to 1, the closer your decimal is to 1, the closer your percentage is to 100, the more likely that event is going to happen. The closer it is to 0, the less likely it's going to happen. Now, in this general vicinity, we're getting really close to 0. That is an extremely unlikely thing to happen. People will often say it can't happen. Technically, it can. For example, winning the lottery. You are probably not going to win the lottery. You are probably going to lose if you ever play the lottery. There is a 1 in a gigantic number chance of you winning the lottery. It's above 0, but not by much. Okay? So, theoretical probability is if we have all of the events that are equally likely, should say likely right here, then the probability of event A equals the number of outcomes in A divided by the total number of outcomes. I like to think of it as ways to win divided by number of ways. Okay. Theoretical probability is used for predictions of what is probably going to happen. The simplest one is flipping a coin and say, I want to get the probability of finding heads. There's one way to get heads. That's the ways to win. But there are 2 ways for the coin to land, heads or tails. The probability would be 1/2. This theoretical probability is used kind of for what could happen in the future. Looking at things that happened in the past is experimental probability. Okay, the probability is determined by performing an experiment, which is why it's called experimental. Okay, that experiment doesn't have to be a science type experiment. It could be conducting a survey, looking at results of things that have already happened. This experimental probability looks back at what did already happen, but not forward to what will probably happen. It cares about what already did happen. The next bullet point is one that I'm going to highlight because it seems odd. It says experimental and theoretical probability will probably not be equal on small scale experiments. What that means is we talked about if I flip a coin, I have a 1 in 2 probability of 1/2 of getting heads. If I flip the coin 10 times, the theoretical probability says that I should get 5 heads and 5 tails. You might get 6 heads and 4 tails. You could get 2 heads and 8 tails. They don't have to exactly equal 1/2. But if instead of performing that experiment 10 times, I flip the coin 10 million times, I might still be off by a couple of heads or tails here or there, but it's going to be very close to 5 million and 5 million. The more experiments you do, the closer you're going to get to that theoretical probability. Okay, so here it says probability of heads equals 1/2. That's one we've already been talking about. The probability of this theoretical probability says that you can expect to flip heads once every 2 attempts. You should be able to reason that that's what we should expect to happen. That doesn't mean that's what will happen. You could get heads 3 times in a row. That is not unlikely. Okay, so for the actual simple probability, that's what this first part is called, simple probability. Our calculations are going to be relatively simple. Number 1, we have a spinner that has 8 equal size sectors numbered from 1 to 8. Find the probability of spinning a 6 for A, and for part B, spinning a number greater than 5. Write your answers as a fraction, decimal, and percentage. So for part A, we want to find the probability of getting a 6. Well, there's 1 6 out of 8 numbers. There's my answer as a fraction. As a decimal would be 0.125. And as a percentage would be 12.5%. Because when we change from a decimal to a percent, we just multiply by 100. Now, if I'm looking for the probability of getting greater than a 5, those numbers would be 6, 7, and 8. There are 3 ways to win out of 8 ways to get a result. 3/8 is 0.375, which is 37.5%. So logically speaking, it makes more sense. It makes sense that you're going to have a higher probability of getting one of these 3 numbers as opposed to just that one number. You're giving yourself more opportunities to win. You are increasing your probability of winning. In number 2, it says 1 card is drawn from a standard 52-card deck. Find the probability of getting a spade. All right, so the probability of getting a spade is, well, there are 13 spades out of the 52 cards. These are both divisible by 13 to give you 1/4, which is 0.25 or 25%. That's about the last super nice probability we're going to have. Because for part B here, it says find the probability of getting a 9 or a 10. There are 4 9s and 4 10s, which makes 8 ways of getting a winning card out of 52. These are both divisible by 4 to give you 2 out of 13. 2 out of 13 as a decimal is 0.15384615338, which as a percentage is 15.38461538%. If we're getting answers like this, the directions will typically tell us to round to a particular place. I'm going to say to the nearest 100th. Because I'm rounding, I'm changing my equal sign to a approximately equal to. That's just the squiggled equal sign. So it looks something like that. Okay. And then for part C, kind of the same idea. Probability of getting a face card. Well, there are a total of 12 face cards. Okay, 4 jacks, 4 queens, 4 kings. These numbers are both divisible by 4. Gives me 3 out of 13, which we're going to have that same kind of gross decimal situation. 0.2307692308, which is approximately equal to 23.08%. All right. Now I kind of just skipped from the long decimal to the percentage there, rounded, but I will give you very clear instructions of what I want you to round to if I want you to round. Excuse me. And then the last example problem here we have made 15 of 21 free throw attempts. That's our experimental probability. Based off of that, they say find the probability you'll make your next free throw. So the probability that you're going to make a free throw based off of what you've already done is 15 out of 21. 15 and 21 are both divisible by 3. So that means we are going to have 5/7 as our probability, which as a decimal is 0.714285743, which as a percentage rounded to the nearest hundredth, oops, helps if I go to the right decimal place, be 71.43%. Now, I wrote these along decimals just so that you can get practice plugging things into your calculator and seeing if they match exactly, which is a really good habit to get into. All right. In the next video, we're going to talk about compound events, and that's where the probability is going to start getting more and more complicated. So make sure we have a strong foundational understanding of the simple probability, because everything comes back to this, but we will get more complicated scenarios. Have a great day, everybody.